What is going on, guys? It's SDL2 here again, and this is the third episode of creating chess in C++. So what I would like to do in this video is first of all show you what I've changed, because I've updated it a little bit. So the very first thing I did was change the texture object to entity, because I felt that fit a bit better. And then I also changed these guys to classes instead. And as you can see, I now have a CPP file for the add move and then move function and the isMouseOver, so everything's not implemented in the H file. So what I also did was create a function or functions for setting the different chess pieces. So for example, I have the set chessman, which basically does the same thing as before, but it does it a bit more structured. So now I have the color string, where I set the actual color string based on what the piece color is. And the same thing with the character. And that's just for basically getting the right texture and the right name for every piece. And then I did the same thing for the pawn, basically. And what I also did was do this for the tile, which is basically the same thing as the set pawn and set chessman, but it's for setting the light and dark tiles. And I broke out some things into separate functions, like I have the move chess piece function right here. So if we're waiting for a move and the piece is not null, then we are looping through the moves. And then we are moving the chess piece. And what this does is, I mean, it's basically nothing new. It's the same structure as before, or the same concept as before. So I'm getting the coordinates from the actual move. This is the, in the move sequence. So the coordinate from that, I'm getting the X and the Y. Oh, missed a space there. And then I'm just getting the mouse point. So wherever the mouse is on the X and Y axis. And then I'm using this function instead of the fucking isMouseOver thing I did before. Yeah, so as I explained, I have these enums for setting the different colors on the pieces. And these I think I had before, I'm not sure. But I basically just want to separate them somehow else without actually having to look at the name. Now I guess we could start working. Now that I've showed you everything new. I'll also show you real quick that the game is the same as before. There are no additional functions to it. It's just better structured, so we can still move around. But obviously I have a lot to do here, because it's a bit glitchy, as you can see. I can also keep moving the pawn twice every time, which is obviously incorrect. And then I want to add some collision and shit. If two pieces collide, and if a piece is in front of another piece, I won't be able to move there, for example. What I'm first thinking of doing is adding the actual move to the different chessmen, as they are apparently called. So I guess I could do the same thing here, but I would like to make a function out of this. Because otherwise there's going to be a lot of mess in this function right here. And I already broke out this switch case, so I might as well make another one. I guess I can pass in the chess piece as a reference parameter, because I want to update the moves for this specific piece and not create a new copy of it. I guess we could do a switch case where we switch the piece. Yeah, it's the piece type. Okay. And yeah, these guys should be private because it's now a class, but that's fine. We'll work on that later. There we go. I'll just pass in the piece, because then we don't have to call that set moves function for every single piece. For the pawn, I want to do this. The exact same thing as before, but the problem is, for this, we are subtracting the actual offset. So what I'm gonna have to do is basically, let me just make a const int. And what should I name this? I'm not sure. Let me just do multiplier for now. If the piece dot color, so I'm actually gonna have to add a color to this. I thought I did. I not? I'm only passing in the actual color. Okay, but that's fine. we can always just do piece.color equals color, and then I will add that piece color. Okay, that's good enough. And let me just rename this to type to keep it simple. And I want to do if the color is piece color black, then I want to set the multiplier to 1, otherwise -1. So if you're following what I'm doing here. Okay, so if they're black, I want it to be the positive multiplier, because the offset is going down, and then the opposite for the white ones, because they're moving up. Now, what I can do is I'm just gonna wrap these in parentheses to make it a little bit clearer. I'll just do multiplier times that, and then multiplier times that. So these will turn negative if they're white, and positive if they are black. Now, if I'm not mistaken, I should be able to remove these. And it works. Just as... Oh, okay. That's not the desired outcome. Oh, of course, because I'm only doing it in set chessman. I obviously need to do it in set pawn as well. So, piece.color equals color. Of course, of course. Yes, there we go. Perfect, perfect. So, the rook should only be able to move either forward, backwards, left, or right. So, for int index is less than window width, I believe. And then just increment index. So, we are going across the x-axis. And we want there to be moves for every single tile on the x-axis. I'll do piece.x, piece.y, and this should be... Let me see. If piece x is greater... Let's do 8 times board size. And I know this might not make a lot of sense right now, because if we're looking at the rook to the very right, I want to fill out to the left. And if I'm looking at the rook to the far left, they should fill out to the right. And then I'm gonna update them as the piece moves around, but that's another step. So what I could do is I could add the move to the piece.x minus index times window width. And I guess what I could do here is set this to 1, because this shouldn't extend all the way. Hold on. Index is actually going to be board size. And then we're going to do index plus equals board size. So we're going to just move this by index. Let me just set 500. Just an arbitrary number. Okay, we still don't have any moves for the rooks. Wait, the board size is 8. Okay. So that's an issue. I'm not gonna be using the board size, I'm gonna be using the entity size, because that should be 64, right? Yes. And then just increase that by 64 each iteration, and that's 512, which means we should be able to get a whopping 8 moves. But since we are looking at index less than window width, we should get 7. And that's exactly what we want. So we're adding the white piece. That's not what I want to do. I want to look at the chessman. This is at 448. Okay, so it's not going to be greater than 500. That's why we are not getting the moves. So if I do the little calculations here again, we should get that number if we do 7. Yes, exactly. So then we can just see if this is 7 times entity size. Now we should have moves. There we go. And I'm able to move it. That's perfect. Now I want to do the same thing for up and down. Or at least up for this piece. So piece.x is gonna be just that. And then it's gonna be piece.y minus index. Yeah, it's the same distance to the far left as it is to the far upper tile, because there are 7 tiles there, 7 tiles there. So there we go. Now we can move, and as you can see, it's still kind of bugged, but that's okay. We have to fix that later. If I'm not mistaken, we should have the same exactly, because that's also at 448. However, this is where the multiplier comes in. For this motherfucker, we're gonna do plus index times multiplier. Or we can just do multiplier times index. Doesn't really matter. I don't know what the fuck I'm talking about. So there we go. Now we have moves in those directions. We have moves in those directions. Okay, progress. Very nice. Now, we know that the else is the other two. We can do the same thing, but for the x we want to do plus, and for this, I think this can be the same actually. So we can actually move that out of there and just focus on the x. Let's see if I am mistaken. That works. That works. That works. And that works. Okay. Now we got the moves for the rook. So we want to do piece, add move. We want to do index. But actually, initially they're gonna be different. So we can always do if piece dot color equals piece color black. So we want to add the else statement. We want to do add move. We want to keep the piece.x, piece.y plus... Hold up. I don't need to do this because I have the multiplier. I can just do that. And then I want to add multiplier times entity size. So we're going to want 3 moves down. Let's just automate this. Do the exact same thing here. Now we can just do index is less than 3 times entity size, and then index plus equals entity size. And then we want to do that, and we want to do multiplier times index. And then I want to do piece add move. Guess I can do piece.x minus entity size, and then piece.y plus multiplier times entity size times 2. Is that right? Yes, that is correct. And now I want to do the same, but for the other way around. So I can just duplicate that. This should be plus. So now the knight can move there and there. And obviously he shouldn't be able to move there. So I guess I could actually scrap these guys, because I do only want to move there. I might add some some slightly darker marks just to show the entire move sequence, but for now I think that's fine. Oh, look at that. It's kind of nice. And what I could also do is just add the same ones for the Y. This should be the same. Actually, yes, it's supposed to be the same as these ones, but they're supposed to be flipped. So this goes over here. Get that plus. Also get that right there. And then this should be minus entity size. And this should be plus entity size, if I'm not mistaken, because the X is gonna be displaced twice to, let's say, the right, and then the Y up and down. Yeah, just like that, just like that. Look at that, look at that. Only 2 more sides to go. Not to brag, but this was actually easier than I thought, you know. Let's add some comments here. Bottom moves, right moves. Now we've got the left moves and we got the top moves. So for the left moves, they should be right moves, but the plus should be minus, and then the top should be the same as bottom, but the Y pluses should be minuses. Let's see if that's what I have to do. Yeah, there you go. Now we've got some moves for this boy. Looking rather nice. And as you can see, these moves are blocked by other chess pieces. So I'm gonna have to add that collision to check that you can actually move there. Otherwise these should not be rendered out. They should be dropped from the vector. Okay, the bishop. This is gonna be interesting because this motherfucker moves diagonally. I actually don't think this is gonna be too hard. This is just basically gonna be some kind of for loop. I think I can add these guys. And now what I want to do is check if width equals height, because it's gonna be displaced. Maybe I have to open paint again so I can understand this. So if we have this crazy good looking 4x4, we have the fucking bishop right there. Then he should be at, let's say he is at 64, 64. Then we're gonna add 64 and 64. So it's gonna be there, and then there's obviously gonna be more tiles down here, so he can move right like that. This might be the way to go. Piece dot add move. Let's do entity X. Let's start with the, yes, we can do plus width. And then we can do, sorry, I have to add the curly braces right there. And this is not entity, this is piece, my bad. And then piece.y, this is where we wanna get the multiplier. So we want the multiplier times height. So that should do it. Let's see. Yes, as you can see, we can now move it. And we also have to be able to move it to the left and then back. Might be able to just add another move where I subtract the width, and this should still be plus height. Let's see if that does anything. Okay. Very nice. Very nice. Now we just gotta go the other way. But since the piece is at the top from the beginning, we don't want to add any moves above it because there's nowhere to go. So I'm gonna save that step for later, because when I move the piece I want to update every single move, so that's gonna be for a later time. Okay, so this guy can move the same, but these, okay, they can also kinda, not really, kinda resets, but that's okay. I think I'll fix that later too. So for the king, this should be fairly simple, because we only want to add, he can go everywhere around himself, right? Or can he only go to the left and the right, top and down? I think so. Should really have played more chess before this video. So we want the X plus entity size, and the Y should be the same. Then we want minus entity size, like that. Then we want the X to be default, and we want the Y plus entity size, and then the same, but minus entity size. That looks good. Let's see if that works. So we got the king right there, I think. Yes. Okay, still a little glitched, but that's okay, I guess. I think it's because this is outside, but that's okay. And then the queen should have every move of the bishop, but then also be able to go to every straight direction like the rook, I believe. And maybe I can simplify this, because we are checking the width in here. Actually, I might not do that. It might mess some things up, so I'm just gonna keep that as is and change this to width. And I will also change this to width. This is actually the height. Let me just change it to offset. So there is no confusion. No confusion. Let's see. The queen. Okay, we don't have any... Okay, I think I know why. Because I'm checking this. And this is never true, because the queen is in the middle. So what I want to do is... I guess I can just... is this gonna be a little messy? I mean, we can always try to run this. It does look rather okay. Let me try something here. I want to get the width minus piece.x maybe. And I want to make sure the width is greater than 0. And then add the entity size. Let me try to add some moves here. Minus offset piece.y. And it's not called offset anymore, it's called width. And then let me comment that out and see if we get any moves to the left of the piece. I think I messed it up, because we're incrementing, so it's just repeating. We want to decrement. There we go. Yes, now we have moves all the way there. Perfect. And then we want to do the same thing, but for the right side. So the offset is going to be the same. We're going to do less than window width. And now increment it, not window. Width plus equals entity size. And then add the move piece.x plus width piece.y. And I should actually change these to offset because it just seems more correct. So the queen. Okay, nothing to the right. Why is that? Okay, I see what's going on here. Because we want to start at 64. I guess what we could do is do piece.x minus entity size. Because then we should get the tile to the left of it. And then we're making sure that it's greater than 0. And then we only want to set the x to the offset. And then the same for this. So piece.x plus entity size. And then we just want to set it to offset. Kinda. Maybe I actually want it to be set at 0 too. Right? Yeah, because 0 is a valid position. And then as I said, we're gonna update it more later. Okay, and that's all the pieces. Done. Quite messy function, but if it works, it works. I guess the next step is to actually update the moves with every single move and then add some collision.